Are you looking at my whiteboard? My paper? Right. So my goal today is to get the second section of homework, hypothesis testing part B done. We've done a fair amount of it. Start to finish, this is essentially how hypothesis test works. We're going to do some homework questions that kind of go through some of these steps. You know, for instance, some of the questions you just find the z-score, some you get a p-value, and some you go all the way to the conclusion. So that's kind of what today's going to be about. So you start off in a hypothesis test with something you want to prove. You want to prove that the percentage of people who like Pepsi has gone down from what it was in the past, or the percentage of people who are going to vote for a politician has gone up. Right? It's more than it was last week. Or that something has just changed. You don't know if it's got bigger or smaller, but you've got a gut feeling that it's changed. And that's what the null and alternate do. You should also, at that point, check to see if your test is allowed. Are you allowed to do a hypothesis test? So this is kind of summary we're doing here. Is the data collected fairly? That's pretty obvious. You want that asked in the right way. You want that. Sometimes it's a simple thing that will catch you. I'll give an example of why you shouldn't use this in this situation. I've got 500 people who work for my company, and I ask every single one of them, do they want to change over from PCs to Mac, right, in their offices, right? We're about to do a refresh. Should we stick with PCs or do we want to change over to Macs, right? Let's say that's the question. And I ask every single person who works for us. There is no point in you doing this. Don't you know the answer? It's like a census. You've asked everyone. So I wouldn't do a hypothesis test if I've asked everyone, for instance. More likely, the thing that fails here is that your sample's not big enough. Remember the NP naught, N1 minus P naught has to be bigger than 10, right? The 10 test. So at least 10 people need to say yes and no for you to be able to do it. You then calculate these guys, the p hat, sample proportion, the standard error of the sample, and the z-score, also in this textbook called z-statistic. So if you see that phrase, they mean that guy. Once you've calculated all these things, you then can get the p-value, which is really the most crucial number, and that's always going to be done with salt. And then you test, and you test, is your p-value, the guy that you got from step 3, is it smaller than the significance level? Always smaller. And if the answer is yes, then the alternate is true. And if the answer is it's no, it's not less than this number, then there's not enough evidence to reject the null hypothesis. And that's us finished. That would be the whole process. So let's show you some of these questions. Question 3 wants you to find what they're calling a z-statistic. I call that a z-score. Well, what am I told? I'm told p hat is 0.65. This is what you're being told, right? You're told that. You're told the null hypothesis is p equals 0.5. You're also told in this question that the alternate was that it's not equal to, right? So it's different than 0.5, and you're going to get your z-score. So your answer is going to go here. Everything I need is here. I already know that guy. So what I'm going to get is the standard error of it, and it's the square root. Will I be using the 0.5 or the 0.65 in my standard error formula? Do I use this guy who has a name he's called P naught? Do I use P naught or do I use P hat?
PO.
Okay, here we go. And it's 0.5 this time, so it's 0.5, 0.5. And oh, they told us, and I forgot to write it down, but they actually told us the sample size was 40. So we know that as well. So go to the calculator. Square root of 0.5 times 0.5 divided by 40. And the answer is 0.079. And to get the Z-score, this is the kind of thing you write down in your cheat cards. P hat, that's the sample proportion. Take away P naught, the null hypothesis guy, yeah, all over the standard error. In this case, it's going to be 0.65, take away a 0.5, divided by 0.079. Go to the calculator, and 0.65, take away 0.5, divided by 0.079. And the answer I get is, what do they want? 2 decimal places, so 1.89. And that's what you put in your box. Are you comfortable with that process? That if I gave you these numbers, you could always find the Z-score, right? We've seen it as many times as, I don't know, we've seen it a few times. So that's a good place to be. So, question 3 does that. So does question 4 in the homework. So that kind of takes us up to there. So question 3 and 4 basically stop here. And let's move on then and do, for instance, question 5. And in question 5, you're being asked to find the p-value. Now you're going to use SALT to do the last bit, but everything that comes before is pretty much going to be done by hand. So I'm picking, which one will I pick? Let's do D. So in question 5D, you're told the Z-score. I know they call it a Z statistic, I'm calling it that. And it's 4.23. And you're told a null hypothesis. And that's P equals 0.25. You're told the alternative, which is P is going to be greater than 0.25. Now, since they've told me the Z-score, I don't need to worry about actually this, now that I think about it, because I already know that number. So to calculate the p-value, it's the probability that you get a Z-score. Now, it's either bigger than this number, less this number, or outside this number. And you know which one to use by looking at what the alternate is saying. The alternate is looking for proof that the answer is bigger than something, right? Bigger, bigger. That's why I know I'm looking for a Z bigger than 4.23, right? If this had said less than 0.25, wouldn't I be doing less than 4.23? Because you have to go one or the other, right? A left tail, right tail, or two tail. So I'm now hitting SALT and show you how that works out. And here we go. I'll shrink this down a little bit. There we are. Okay, so distribution and calculators, normal. It's a z-score, so 0 for the mean, 1 for the standard deviation. I want a bigger than, so that's a right tail. See a little picture. And I want it to be bigger than 4.23. And the answer I get is that guy there. So my p-value is 0.00001. Okay. Now, you're asked to do these answers to 4 decimal places. To 4 decimal places, the answer is 0, 0, 0, 0. That doesn't mean that the answer is 0 probability. Doesn't it mean it's so small that if you round it to 4 decimal places, it looks like a 0, right? So if you typed in all of that instead of this, WebAssign may have said you're wrong. Although you've written down the more accurate answer, you haven't rounded it off. So always pay attention to how many decimal places they say. You know, maybe you get a z-score to 5 decimal places. If you write that in, but it only wanted the answer to 2, it could quite easily say that you're wrong, right? WebAssign's not too clever that way. So just to be aware of that little hiccup. Do you want to see another one of calculating the p-values? Okay, let's pick a not equal to. So a not equal to could be question 5a. And you're told the z-score in 5a is 2.60. You're told that the null hypothesis is that p was 0.1 and that the alternate hypothesis is that it's not equal to 0.1. So our p-value is going to be the probability, and these are the ugliest looking ones, and I'm not sure you can see what I'm writing. Okay, let me go back in here. No, there. So here's our p-value. That's what we got out of salt. That was the 0 I was talking about a minute ago. Right, this one, you're told the z-score, you're told the null and I alternate, and you're being asked to get the p-value. When it's these guys, it's a little bit messy. It's less than this guy and or more than that guy. So I'll hit salt again. And I'll show you what that one looks like. Okay. Still normal distribution, still 0 and 1, that's not going to change. If you want to do the outside guys, the 2 tails, then you just go here and you put in your 2.6 because it's negative on the small side, and you put in your 2.6 on the other side. And the answer you get is 0.00932. We'll see this in a second. So it's 0.00, and I'm just writing to 4 decimal places again. So there is your p-value. When you do hypothesis testing, these numbers are typically very small. In fact, the smaller they are, the more evidence there is to say that this is true. It sounds back to front, but that's the way it works. A small p-value indicates that the alternate is true. And then you say, well, how small does small have to be before the alternate is true? Well, it has to be less than 10%, 0.10, or 5%, 0.05, or 1%, 0.01. They're the standard kind of fixed values that we use to decide is something statistically significant. Is that in fact true? Are we good with the p-values? Want to say another one? Are we good? Right. So bigger than, go that way. Not equal to, do the two-sided thing, right? The two-tailed. If it, we haven't done a less than, but can you imagine a less than? If that was less than something, wouldn't you do a z less than somebody? That basically is what question 3 was about. Question, is that 3 I called that? Question 5, I should say. Yeah, that's fair. Question 6, 7. Right, question 6 and 7 now. They take things just a little bit further, but it's only the way that they phrase it. So I'll read it out to you rather than jump back and forward. A hypothesis, this is question 6. A hypothesis test is done to determine if the proportion of a certain ethnic group have blood type A that's greater than 30%. So we are trying to prove that the proportion of people with that blood group is greater than 30%. So that sentence has basically set up the null and alternate, right? If you want to prove something, it goes here. What's the null? Same number, but equal to. I guess I should put an extra 0 to be precise. In this story, they got 1,000 individuals, and 350 of them had that blood type. So what they've just told me there is that p hat is 0.35, right? That was what that was about. They then go and say that the z-score, so they've done that for us, ended up being 3.45, so I don't need to calculate it. And they tell us that the p-value ends up being 0.0003. So basically, they've done all the calculations for us. So let's see what they're asking us to do. They want us to write down what p naught is equal to. They want us to write down what p hat is equal to. And they want us to write down the p-value. Sometimes you get questions that are so simple, you'll talk yourself out of the answers. So I didn't need to calculate anything. Well, virtually, said that maybe. It was all given to us. Right. What number, based on the story I've just read to you, is p naught?
Null hypothesis, so 0.3.
That's it. Now, it wasn't written down like that. It was an English sentence that I wrote out to you, but as I was writing, I wrote this down. So I guess you had that to do, right? Would you agree that p hat was 0.35? And when it asks you for the p-value, so there was no calculation. It was just a matter of reading a story where they told you stuff, and the stuff they told you was connected to these things. Let's look at 7. It says in each case, calculate the p-value. And we've actually done that one. That's like the other questions, so I won't do that. We've done the left-handed, so I won't do that. Right, let's move on now. Question 9. A certain magazine reported that in their survey of 550 randomly selected adult American Catholics, 58% answered yes to the question, do you favor allowing women to be priests? Okay, so keep track of that. The sample size was 550. Out of that 550, 0.58 were in favor of women priests. We are now going to start our little process. Let's do H0 and HA. It says in question A, set up the null and alternate hypothesis for deciding whether more than half American Catholics favor women priests. So you're trying to prove that this value for the whole population is more than half, right? So they said it in English, set up a null and alternate hypothesis for deciding whether more than half, that was a bit where I stopped, more than half. This fella is always the same number, but with an equals. Right? Now, if they said a different story, we want to prove that something's less, when you say less than 0.5, we want to prove that it's different from half, right? Not equal to 0.5, right? You've only three decisions, bigger than, less than, or not equal to something. And that's that question done. Part B. We are looking for the conditions that are necessary to do the hypothesis test. And we're meant to click on all the ones that apply. And they give you quite a few things. I think there's what one do. There are 6 requirements, but one of them says the sample must be random. So it probably wouldn't be a good idea to ask male priests that question, right? Because that's not a population that's random, isn't it? You want all Catholics. So that would be one that you check. The sample should be large enough. Isn't that true about almost everything that we do in statistics? So you pick that one. And then they have a dot, these, and it's written like this, n p naught and n 1 minus p naught must be greater than or equal to 10. Aren't really those two the same thing? When you say the sample has to be large enough, it doesn't not mean this, right? That's how we check, is it large enough, right? And basically, was there at least 10 people who said yes? Was there at least 10 people who said no? And then it says, are these conditions met? And we'll assume that the answer was yes. Then we move on to calculating the Z-score. Well, I have some information, but I'm missing a few pieces. In particular, I'm missing the standard error. So it's going to be the square root of P naught, 1 take away P naught over N, 0.5, 0.5, 550. And they want 2 decimal places, so I'll try and remember to do that at the end. The square root of 0.5 times 0.5 divided by 550. And that's 0. Well, I'm not sure I want to do 2 decimal places yet. The final answer I will do 2, but this one I'll do a little bit more, just to be safe. So the Z-score is P hat take away P naught over the standard error. And that's 58.58. Take away 0.5 over this guy. And that's the guy I'll do with 2 decimal places. So 0.58, take away 0.5, divided by 0.0213, and the answer I get is 3.75. Now I'm happy. That's something you should probably always do. If they want the final answer to 2 decimal places, anything that you needed to calculate before you got the final answer, just be a little bit more accurate with it. Maybe do it to 3 decimal places or 4. And that'll save you having little hiccups where you get the answer 3.75, but the book thinks it's 3.76. You know, there's going to be a little bit rounding off if you're not careful. Are we good with that so far? Do you think that based on this Samplify 50 and the fact that 58% were in favour, do you think that's enough evidence, that 58, to prove that the entire Catholic population, more than 50% believe it? What's your gut feeling? Do you think 58, and especially this Z-score, is going to go in that direction? Well, let me phrase it this way. What is an unusual Z-score? Can you remember Z-scores had values, but when did they start getting weird and outlierish?
Outside -3 and +3.
Right, so if you see a Z-score like that, it's a big, big chance that you are going to get this is true. So let's take it on to the next stage, because we're kind of going through the whole step now. D, we're going to get the p-value. So that's the probability that you get a Z-score bigger, less, or outside 3.75. Well, we're looking for a bigger than. You see, whatever that is, the p-value uses the same one. Now, this guy is going to be done with salt. So I'm hitting the salt button, even if you can't see it. Just trust me, I'm putting it in. I'm going to distribution, putting in bigger than, I'm typing in the number 3.75. And the answer I get is 0.00009. Now, if you round this off to 2 decimal places, let's check, is it 2? Oh, they want 4 decimal places. You get 0.0001. And there is your p-value. It's not 0, but it's darn close to it. And when your p-values is really small, you have got the evidence that you're looking for. So far, so good. So in question E, you've got one of those pull down menu things where you complete a sentence and it looks something like this. This is the written part. I'll put in red the choices that we're going to use. So on the basis of the p-value, make a conclusion. Now, what they haven't told you yet, but if you read the thing, they told us that alpha was 0.05, which seems to be the only number they know for significance level. So, the first pull down menu says you reject the null or you do not reject the null. Okay, so here is how you do that. Your test, right? Is your p-value less than alpha. In this case is 0.0001 less than that guy. And your answer will be yes, it is, or no, it's not. In this case, that tiny decimal is less than this. Okay. If the answer is yes, your conclusion will be essentially that HA is true. That's your conclusion. HA is true is phrased in a number of ways. If someone says the evidence is that you can reject the null hypothesis, it's the same thing as saying the alternate is true. So you just got to get used to that there is more than one way of saying HA is true, right? So whenever they have a choice, reject the null hypothesis, they'll mean that. I've seen ones where they go and they say there's enough evidence to reject the null hypothesis, and so the alternative is true. That big long sentence is used in quite a few textbooks. Now, they have an F part, which isn't typical. So they ask you to find a 95% confidence interval. And if you were going to do that from scratch, it would be p hat plus or minus 1.96 times the standard error of p hat. Hopefully you still remember that guy, right? So the question if we would do that, if I put in the value that we have for p hat, which is, where are we, p hat? 0.58 plus or minus 1.96 times the standard error, which was 0.0213, you get an interval 0.539 up to 0.621. Now, if you look at that confidence interval, isn't that also telling you that the proportion of people who want female priests is somewhere between what, about 54 and 62%, but aren't they all bigger than 50%? So isn't that really verifying what you've already decided? There is enough evidence in this sample that we took to prove that that is the opinion of Catholic people and whether women should be priests. Are we good with that? So it's a long question, but once you've done a couple of them, as I've said in other situations, you've pretty much done all of them. So I'm just seeing what the time is. Yes, we've got time for one more. They're long. Right, that's 11. Okay. I'm not sure which one I want here. Okay, I guess we're going to do, I was hoping for something more interesting, but I'll take what I can find. Question 14. Like any seeds, watermelon seeds lose their viability over time. So if you keep seeds for growing something, you could probably keep them for 1 year and they're okay. If you kept them for 10 years, most of them won't germinate, right? So that's what they're on about. Now, if they're stored in a cool or dark location, then they have a better chance of making it. So this guy selects sample of 50 watermelon seeds, and he finds out that 28 out of the 50 actually germinated, right? They're ready to put in the ground. So that ends up being 0.56. And that was actually question A, find p-hat. He wants to know whether or not, if you take the seeds and you keep them in a dark place and you put them on wet paper, whether 50% or more are going to generate. So he believes that if you do that, it's going to be more than 50%. So the null hypothesis and the alternate hypothesis. He thinks that if he does all those things, he will get more than 50%. And the alternate is that it's still going to be 50. That's part B done. Part C is get the z-score. So I've got most of what I want, but I'm still missing the standard error. So it's going to be, well, 2 lots of 0.5 divided by 50. So square root of nothing 0.5 times another nothing 0.5 divided by 50. And the answer I get is 0.071. And the z-score then, if I give myself enough room, so I'll have to do it down here, is p-hat, take away p-naught over the standard error. 56, take away 5, divided by 0.071. And 0.56, take away 0.5, and then divided by 0.071. And the number I get is 0.8. What do they want it to? 2 decimal places. So 0.85. Round that off. Right, so far so good. And there's a pretty standard hypothesis test. If you keep your melon seeds in a dark room with damp paper, will more than 50% of them germinate. He did it with 50. He got 56 germination. That sounds good. At this point, we know that the z-score is 0.85. Question D does not ask you to find the p-value, but it does tell you the significance level that you have to use. And it gives you 4 choices. And the 4 choices are basically, is there enough evidence or not? So although they don't say it in D, you need to calculate it. So I'm going to go to salt. I'm going to put in all the numbers as I've done in the past. And make sure you're on distribution calculation. I'm looking for a greater than this time, so got that set up. Going to put in the z-score, which was 0.85. And the p-value that I got out of salt to, say, to 2 decimal places was 198. Right. Let's take this home. I got a p-value here of about 0.2, right, if you round it off. Is my p-value less than my significance level alpha? in this question is 0.198 less than 0.05. And I'm saying no. And when it's a no, your conclusion is not enough evidence to reject H0, right? You have not enough evidence to prove that it is actually bigger than 50%. This just happens to be, this one sample just happens to be bigger than 50%, but in the randomness of the world, could the next one be 49%, right? It could be a little bit, right, either side. If I still truly believe that this was true, what is the fact that you've said there's not enough evidence to reject H0 doesn't mean that this is true. Doesn't mean that this is true. It really just means, you know, the jury's out. We haven't really made a decision yet. So what would be the only viable way of redoing this experiment that might get evidence if it was there? What could you do?
Increase the sample size.
That's almost the answer to every one of those questions, isn't it? If there's no, you can't change the numbers, right? So for the last few moments, let me talk about how some people, unscrupulous people, cheat. Right, maybe this guy's writing a book about storing seeds, right? And he's doing his experiments, and he did this experiment and it didn't work, right? He never got the evidence. Couldn't he take another 50 seeds and do it a second time? And another one, and another? Couldn't you keep doing it like 20 times? Eventually, wouldn't you get one where this was so big that you finally got a p-value that worked? So essentially what you do is keep doing the experiment till you get the answer you want. Analogy, if you had kids, can you imagine kids keep on asking you something until they get the answer they want, right? So the 15 times it failed, nobody knows about it. The only time that you know about it is, well, on the 14th of August, I did it and 82 of my, 82% of my seeds germinated. Now with that kind of number, you would get evidence here. So that is cheating, right? It truly is. So if a company or someone does something multiple times, but only tells you the one that favors what they want to be true, that's just it's just lying, right? Even although the statistics might look right, you've got to be a little bit suspicious of people who do that. Other examples of that. Do you know politicians conduct polls all the time? They ask people things. Can you imagine a company that asked Harris Poll, Gallup Poll, some company like that, to find out if people are in favor of a no-fly zone in Ukraine? And they want the answer to be yes. You do a poll, you don't get enough evidence to prove it, right? You do a second poll, you do a 20th poll. If you keep trying hard enough, won't you eventually get one fluky poll that will agree to almost any stupid, no, not that's a stupid one, but any idea that you would ever want? But which one do they publish? They only publish the one that had the answers that they wanted. Oh, on the 14th of August, we conducted a poll with 1,000 people and 57% were in favor of whatever it is you were in favor of. That's why that's one of the reasons you should be very skeptical of political polls. It's very rare for a political party to publish a poll that is unfavorable to their point of view. Right? They're quite good at having polls that say bad things about the other team, right? But they're not going to publish any polls that say bad things about themselves. So that is last name, attendance.